The chi-square test of association. Let's learn how to determine whether two categorical variables are related. The chi-square test of association begins with two hypotheses. The null hypothesis H0 states that there is no association between the two categorical variables in the population. The alternative hypothesis Ha states that an association does exist. The key idea is simple. If H0 is true and there's no real association, then the observed counts in each cell should be close to what we'd expect by chance alone. The test statistic is the chi-square statistic. It equals the sum over all cells of the quantity O minus E squared, divided by E, where O is the observed count and E is the expected count in each cell. Each cell contributes one piece to this sum. Cells where O and E are close contribute little. Cells where they differ a lot contribute a lot. When observed equals expected everywhere, the chi-square statistic is 0, meaning there's no evidence against the null hypothesis. To convert the chi-square statistic into a p-value, we need the degrees of freedom. The degrees of freedom equal r minus 1 times c minus 1, where r is the number of rows and c the number of columns. For our smoking example with 5 education levels and 2 smoking categories, that's 4 times 1 equals 4 degrees of freedom. The chi-square distribution with 4 degrees of freedom is right-skewed. It starts at 0 and extends to the right. The rejection region sits in the right tail. If our test statistic falls in this shaded region beyond the critical value, we reject the null hypothesis. For alpha equals 0.05 and 4 degrees of freedom, the critical value is 9.49. Let's calculate the chi-square statistic for our smoking and education example. For each cell, we compute O minus E squared over E. The high school smoker cell has an observed count of 12 and expected of 8.3, giving a contribution of 1.96. The undergraduate smoker cell has a large contribution of 3.6 because 32 smokers were observed, but 43.55 were expected. Adding up all 10 cell contributions, we get a chi-square statistic of 13.20. Our chi-square statistic is 13.20 with 4 degrees of freedom. Let's place this on the chi-square distribution. Here's our test statistic at 13.20. The p-value is the area in the tail beyond this point. Using a chi-square table, we find that the p-value falls between 0.25 and 0.1, very close to 0.1. Since the p-value is less than our significance level of 0.5, we reject the null hypothesis. There is statistically significant evidence of an association between education level and smoking status. There are actually 2 versions of the chi-square statistic used in practice. The Pearson chi-square, which we just computed, uses the straightforward O minus E squared over E formula. Yates' continuity-corrected chi-square subtracts 0.5 from the absolute value of O minus E before squaring. This correction produces smaller chi-square values and larger p-values, making it more conservative. Both versions are commonly used, but you should know both exist. Let's wrap up. The chi-square test of association tests whether two categorical variables are related in the population. The test statistic sums up all the O minus E squared over E contributions. Degrees of freedom are R minus 1 times C minus 1. We compare our statistic to the right-skewed chi-square distribution. If the p-value is less than alpha, we reject the null and conclude there is an association. And remember, Yates' continuity correction provides a more conservative alternative.